technology served in a capsule. So in today's capsule, we are going to talk about the energy flow in an IC engine vehicle. How is the power flow happening and how is the IC engine working? So that is the topic that we are going to discuss today in detail. So for that, we are going to move on to the class board and we are going to discuss about the energy flow diagram. So let's get on. So if you consider an IC engine vehicle, you have a 12 volt battery pack in it. Now this 12 volt battery pack is critical for many applications. The first major application that we have to talk about is cranking the vehicle. So if you remember in the previous video where we were talking about history of electric vehicles, we have seen that mechanical cranking is one of the most difficult work to be done to start the engine. So a person has to physically crank the vehicle so that it starts. So in 1911, with the invention of starter motor, it has completely changed the scenario, right? Now this cranking is actually drawing some energy from the battery pack which is available inside the vehicle. So for that particular purpose, the battery pack is very critical. So coming to the battery pack design, we can see that the battery pack varies. That is, we have battery packs which are ranging from 12 volt 8 ampere hour, which will be used for small vehicles which are around 100cc vehicles or maybe 125cc vehicles. Then if we come to a 650cc range, we can see that the battery pack comes to around 12 volt 16 ampere hour. And then if we go above say 1200cc, we can see that the battery pack will be around 12 volt 35 ampere hour. And then again if we go on increasing maybe greater than 2000cc, we can see that the battery pack again increases. So basically the battery pack capacity increases with the increase in the load. So here if you observe, the load that we are going to talk about is the load which is attached to the starter motor. So what is the load which is attached to the starter motor? Yes, it is the IC engine. So when the IC engine capacity increases or its piston sizing increases or its cylinder region increases, then what happens? We have to have more energy delivered so that the piston motion can be controlled. So for that we'll be requiring a bigger battery pack. Now this is one of the major role of this battery pack, that is we have a starter motor. So if you observe in this particular figure, we can see that the IC engine is directly coupled to the wheels through the differential unit or through the transmission unit. Now the starter motor is coupled to the IC engine and the starter motor will be drawing the power from the battery pack which we have taken as a 12 volt 60 ampere hour battery pack in this case. Okay. Now what type of batteries do we use in vehicle? So all of you know the battery pack that we use in the vehicle is a lead sulfate battery pack, or it is called as a lead acid battery pack. So lead acid battery pack therefore will have to deliver its energy to the starter motor. Now along with the starter motor, what all are the other components which is receiving or consuming this energy? So when you are sitting in a vehicle, when you are entering the vehicle and you sit inside the vehicle and you turn on the key, and when you turn on the ignition, what happens? The moment you turn on the ignition, a relay will be operated. Now this relay will be doing what? It will be trying to connect the energy flow from the battery pack to the starter motor. Now along with this, we have to see that the next operation that should happen is the spark plug should be activated, provided this is a SI engine, that is spark ignited engine. So in a petrol engine or in a SI engine, that is spark ignited engine, you will be requiring a spark plug to initiate the ignition process. So coming to this figure, we can see that the spark plug will be here, which will also be receiving energy from the battery pack to provide or produce spark in the IC engine. ECU is another important component which is available in a vehicle. ECU can be called as the brain of the vehicle. Now what is ECU? ECU is electronic control unit. So ECU for an engine will be the brain of that engine. Same way we'll have number of ECUs in a vehicle. These ECUs will be interconnected and they will be communicating over CAN bus communication protocol. So when we talk about the IC engine alone, we have an ECU which will have some dedicated operations. The dedicated operations involved, first one will be the fuel injection. So ECU has to monitor and control the fuel injection that is happening inside the engine. So So as we all know, today fuel injection based vehicles are more, that is electronic fuel injection, EFI based vehicles are coming into market a lot. So gone are the days where we have carburetor based engines. So electronic fuel injection is very important, and since there is an electronic component, ECU plays a very pivotal role. The second aspect that the ECU has to control is the spark timing. So spark and ignition timing is very important for controlling the vehicle operation. Along with this, the ECU also has number of other applications, but these are the two critical applications which are going to happen. Now we'll be talking about the spark plug operation as well as ECU in tandem. So let's start with the first agenda of ECU. So in the fuel injection process, we have to inject the fuel into the cylinder, and for that there is some logic behind it. So let us find out what that is. Here we have to talk about the term which is called as AFR, that is air fuel ratio. This is the ratio of mass of air to mass of fuel combination inside the cylinder. So in this case, I'll be calling it as A by F. So in a typical vehicle, we are going to consider a stoichiometric ratio of around 11.5. So if the AFR value is greater than 11.5, then the vehicle is said to operate in the lean region. And if the AFR value is less than 11.5, then it is called to operate in the rich region. Now what does this mean? If you look at this, you can see that when the AFR value is greater than 11.5, that would mean that the air quantity is increased or more than the fuel quantity. And if it is in the rich region, we can see that AFR value is less than 11.5. That would mean that the air quantity is less while the fuel quantity is more. So this plays a critical role in the operation of the IC engine. For example, if we are operating in a first gear scenario where we are climbing up a hill or we require more torque, so in that scenarios we can see that the AFR value will be less than 11.5. That is, a rich mixture will be present inside the cylinder. But if we move on to the next case where we have the lean region, we can see that if the AFR value is greater than 11.5, that would mean that we are moving on a fifth gear or a higher gear, and we are cruising. We are cruising on a road where torque requirement is less and speed is more. So it's critical that when we are calculating, or when the ECU is calculating the AFR value, this should always be within a limit. We cannot allow the AFR value to be too small or too large, because it will actually affect the life of the engine. So in the context of finding out how the IC engine injection happens, we have to talk about one most popular equation, which is known as the ideal gas equation. That would be given as PV is equal to nRT, where P is the pressure inside the cylinder. So since we are talking about in terms of IC engine operation, P will be the pressure inside the cylinder, V will be the volumetric motion inside the cylinder, that is what is the volume consumed inside the cylinder, R is the ideal gas equation, and T is the temperature inside the cylinder. Now N indicates the number of moles of air which is given inside the cylinder or coming inside the cylinder. So the number of moles will be equal to the mass of air injected to the molecular mass of air. So this equation could be used to find out the mass of air which is coming inside the cylinder. So in this case, what happens is we'll have some sensors inside the IC engine, and this dedicated sensors will be giving us the data on the pressure inside the cylinder through something which is called as MAP sensor, and this MAP sensor is also can be expanded as manifold air pressure sensor. The temperature can be obtained using a sensor called as an IAT sensor, which stands for intake manifold air temperature sensor. So that would give us the information on P as well as T. Now R is an ideal gas constant, which is a constant, and V is the volumetric area or volume inside the cylinder, that can also be, or sweep volume inside the cylinder, which can also be determined. So finally we'll be able to find out N. N will be giving us the number of moles. So N is equal to PV by RT. So once this N value is obtained, we can use it to find out the mass of the air which is coming in, because we know the molecular mass as well. So from equation 2 we can find out F is equal to N multiplied by MM. Now this F value is very critical, so that F value will be given here, and we already know the stoichiometric value of AFR to be around 11.5. So the ECU has to decide based on inputs. What are the inputs? Input will be the throttle condition, then it can be the speed measured by sensors. All these inputs will be used by the ECU to decide what is the amount of fuel to be injected. So we'll be obtaining the air value, so it will decide what is the amount of fuel to be injected. So fuel injection is actually a very critical part of the ECU operation. Coming to the spark and ignition timing process, we can see that the spark timing has to be proper. So when we talk about an IC engine, the IC engine will have a cylinder like this with two inlets. So this will be the inlet through which the air plus fuel combination will be coming, and this will be the outlet through which the exhaust gas will be going out. Now inside the cylinder we'll have a piston. This piston is the thing which is actually connected to the crankshaft, and it will be moving. So crankshaft is something which helps the vehicle to move. So here we can see the piston has two major operating points, or what are known as limits. So this is known as bottom dead center, and this is known as top dead center. So this piston has to move from the bottom dead center to the top dead center. So when the system or the piston reaches the top dead center, then what happens is the air and the fuel mixture comes into this area, and then there will be a high pressure created because of the motion of the piston upward. Now this high pressure, along with a temperature development which can happen differently in SI engine and CI engine, an explosion will happen in this area. This explosion will therefore push the piston down to its bottom dead center position. So it's very much critical that this explosion happens on time and properly, because if it doesn't happen properly, then it can actually damage the piston head as well as it can damage the entire operation. So the operation is completely different in the case of a SI engine and CI engine. In the case of a SI engine, we can see that we require a spark plug. The spark plug is critical to combust or to ignite the petrol fuel which is coming inside this cylinder. Now if we consider the CI engine, we can see that diesel has this property to explode or expand when there is a high temperature and pressure created. So therefore in CI engine we do not require a special spark plug to cause the ignition inside the cylinder. So that is why this is aptly called as compression ignition engine. So in petrol engine we can see that the operation is completely different. The petrol cannot expand or explode using a compression. So therefore it requires a separate entity which is called as a spark plug to cause the sparking inside the cylinder and therefore initiate the ignition. So therefore this sparking has to be done properly, and that spark and ignition timing has to be monitored by the ECU. So those are the major sources of energy consumption in an IC engine. So we have the starter motor which will be consuming energy for cranking, and we have the ECU and the spark plug which will be consuming energy during its operation or during the ignition process. Along with these, we can see that there are other auxiliary vehicle loads as well which will be consuming energy. This would include the headlamps, then there would be lamps and lights inside the vehicle, the air conditioner or AC, then the music system. All these things would be consuming energy from the battery pack. So basically, once the vehicle is on the move, the battery will be drained to a certain extent. So we have to try to recapture this energy. So for that, in the vehicle, you can see that there will be an alternator which will be coupled to the IC engine. So here we can see there is a coupling done to the IC engine, and this alternator will be producing a 3-phase AC supply at a terminal voltage of 12 volt AC. So that is the output of this alternator. But we know that the battery would require DC power to be given to it, and since the voltage is 12 volts, so it will be 12 volt DC. This power therefore has to be converted from the 12 volt AC at the output of the alternator to the DC, and for that we'll be using a rectifier unit which will be doing the AC to DC conversion. So this in a capsule can be talked as the energy consumption is done by the starter motor, the spark plug, the ECU as well as the auxiliary vehicle loads, and the charging would be done using the alternator which will be producing a 3-phase AC output and which has to be fed to a DC battery, and therefore we have the rectifier unit which will be converting AC to DC. So that's it for the video today, guys. Hope you liked it. This is the energy flow process that is happening in an IC engine. So if you liked it, please subscribe, and we'll be coming up with more exciting videos. See you.